Right, so in my previous video, I was actually explaining the definitions and laws of exponents. So here, what am I going to do? I'm going to go take you through some examples um, where we are going to apply the definitions and laws of exponents to simplify exponents. Right, so here's the first one. So they want us to simplify 10 to the power of 2x times 3 to the power of 2x all over 25 to the power of x times 6 to the power of 2x minus 1. Right. So what is the most important thing that you need to understand when you're doing this? For you to be able to do this, especially if your basis or your exponents are multiplied, what is it that you have to do? You have to split. You have to split the basis. You have to split the basis by doing what? By prime factorizing the basis. All right. So let's do that. Right, so how are we going to split 10? So 10 is going to be, you can use your calculator also to prime factorize, as your calculator is the function to do so. Right, so if we split 10, it's going to be 2 times 5. And then your exponent was 2 to the power of x. And then 3 is 1 times 3, so there's nothing we can do. So we can just write it as 3 to the power of 2x all over, and then 25. You'll see that if you do that, it's going to give you 5. 25 can be written as, remember these are exponents, it can be written as 5 to the power of 2. 5 to the power of 2, but because of the x, that is going to be 5 to the power of 2x. Because of the exponent of x, it's going to be 5 to the power of 2x. And then 6 can be written as 3 times 2. 3 times 2. All that raised to the power of 2x minus 1. Right. Then what we do after that, we distribute our exponent. Right. And then we do the same here. Right. So what do we obtain? We obtain 2 to the power of 2x times 5 to the power of 2x, and then 3 to the power of 2x, all that over 5 to the power of 2x, and then 3 to the power of 2x minus 1 times 2 to the power of 2x minus 1. Then what we do here, from here we apply our laws. We can also apply, okay, I forgot the numbers, how I numbered the laws, but then we can just apply. You can see that on top, we don't have any like basis. Also at the bottom, we don't have any like basis, but if you look on top and at the bottom, you see that you have like basis. If you look at the base of 5, if you look at this exponent, 5 to the power of 2x, you see that you also have 5 to the power of 2x at the bottom. So these two can cancel because they actually look the same. And remember, our exponents are multiplied. Our bases are multiplied. And then, do we have anything similar at the bottom and on top and the bottom? No. So which means here we are left with 2 to the power of 2x times 3 to the power of 2x all over 3 to the power of 2x minus 1 times 2 to the power of 2x minus 1. So we can also apply the law that if we have like bases and they're being divided, we keep the base and we subtract the powers. So let's do that. So let's keep the base. On top we have 2 to the power of 2x, and then at the bottom we have this. So we must subtract our exponents, our powers. So then minus. One of the mistakes that students always make, they forget to put the bracket, because if you don't put the bracket, then you're going to make a mistake. Because here, remember, you subtract, so this negative sign will obviously affect this exponent. So you must put it in the bracket. So you have 2x minus 1. Then this will be, so then we are done with the base of 2. So let's go to 3. So 3 on top we have 2x, also minus bracket 2x minus 1. Right? Then let's finish this. This is going to be 2 to the power of 2x, negative times positive, negative 2x, negative times negative, positive 1, times, and then 3, 2x, negative times positive, negative 2x, negative times negative, positive. And then our final answer, therefore, is going to be negative 2x minus 2x, that's 0. So this will be 2 to the power of 1 times, and then this side 3, 2x minus 2x, they cancel, then you are all left with 3 to the power of 1. So this is 2 to the power of 2 to the power of 1, that's 2, 3 to the power of 1, that's 3, 2 times 3, that's 6. And that's our final answer. Right. Thank you for watching. I'm going to, in our next video, I'm going to do another example. Right, so this is our example number 2. So I'm going to take you through example number 2, simplification of exponents. Right, so now we know that for us to be able to do this, we have to split our bases. We have to prime factorize our bases and split them. Right, so how can we split 9? Right, 9, you know that if you write it as an exponent, it is the same as 3 to the power of 2. But remember, you had this power of 2x plus 1. So you have to include a bracket and then write the 2x plus 1. Right, why am I putting a bracket? Because remember, this was our base. But then after prime factorizing, so now I actually get, if I write as an exponent, I get 3 to the power of 2. So it is important that I put a bracket there, because this will have to be multiplied by that according to the laws of exponent. Then I have 2, there's nothing I can do, it's going to be 2 times 1. So I can write this as 2, I can just retain that, 2x plus 2. Then at the bottom, I also have 3. So there's nothing I can do, I can also just write that as 3 to the power of 3x plus minus 2. What about 12? 12 can be written as 3 times 4. It can be written as 3 times 4, but we know also that 4 can be written as 2 to the power of 2. So we can write this as 3 times 4. But then we know that 4 can be written as 2 to the power of 2. So that's what we're going to do there. We're going to write this as 2. Let me use... So we're going to write this as 2 to the power of 2, bracket, what was our exponent? Our exponent was x plus 1. Right, now we know. Then what we do, we distribute, because if we have something outside the bracket, we must multiply it by that is inside the bracket. So this will be, let's distribute that, and we can also distribute this there. And the biggest mistake that students always do, they can all forget to multiply this and this, or to distribute this to this. They only distribute it to this, and then if you do that, then you're going to get it wrong. Right, so what are we going to obtain? We're going to obtain 2 times 2x, so we're going to have 4x, 2 times 1, that's plus 2, and then we have 2, there's nothing we can do there, 2x plus 2, and then at the bottom, what we obtain, also there's nothing, so let's just write that, minus 2, and then here at the bottom, there's a 1 there, 1 times this whole thing, it retains, so we're going to have 3 times x plus 1 times 2. Then if we multiply this times this, we obtain 2x, was 2 times x, 2x, then 2 times 1 plus 2, like that. Right, again, you can see that our exponents on top are multiplied, and then at the bottom they're also multiplied. So if we see something similar on top, things that actually look the same, we can just get rid of them so that we don't waste our time. So as you can see, this is like multiplying the same numbers. It's It's like dividing the same numbers, like 2 divided by 2. I mean, then we obtain 1. So we can actually take out this and this. So these two can cancel because they look the same. Then what we have at the bottom, what is left, we have on top 3 to the power of 4x plus 2. Then what we have at the bottom you can see that we have like bases that are actually multiplied. So we can, if we apply law number, that was law number 3, summation law, that if I have the same basis, if you have the same basis and they're being multiplied, you can add the exponent. So if we do so, what do we obtain? Right. So what are our exponents? Our exponents, our powers, we have 3x. So 3x plus x, we obtain 4x. And then negative 2 plus 1, we obtain negative 1. So our final answer therefore is going to be, right, what do we have here? Here we have like bases that are being divided. So what do we do? So according to law number 4 from our previous video, if you have same bases, if you divide like bases, what you do, you keep the base and then you subtract the exponent. Remember, you write the one on top first. So you're going to have 4x plus 2 minus, in bracket, 4x minus 1. Right, if we do so, what do we obtain? Right, you see that here we're going to have 4x plus 2 minus 4x, because negative times positive, minus 4x, and then negative times negative, that's positive 1, right? So if we do that, 4x minus 4x, and then we have 2 plus 1, so that's going to be 3 to the power of 3, and that is equal to 27. Right, thank you for watching. I'm going to do another example after this, right? So for more examples, subscribe to our YouTube channel. Assist. Thank you. Right, so as promised, I've decided to include another example of addition and subtraction of fractions with variable exponents. Right, remember we said that during addition and subtraction of fractions with variable exponents, we reverse law number 3. So if you have a to the power of b plus c, we can also write that as a to the power of b times a to the power of c, vice versa. We do this to split the exponents, and then after that we factorize. So we are going to do the same here. Right, so let's split this. 3 to the power of 2x plus 2 can be written as 2 to the power of 2x times 3 to the power of 2. Plus this, we can split it to 3 to the power of 2x times 3 to the power of 1. I don't have to write the 1 because it will retain the answer. Right? The same applies, 3 to the power of 2x times 3 to the power of 2. They are separated by a negative. Then this can be written as 3 to the power of 2x times 3 to the power of. Right, the biggest mistake that students always make, probably because of lack of understanding of algebra, they then tend to try to split, to cancel these. That's not correct. You are not allowed to do that, because these are separated by a plus or minus, so you can't do that. So what is it that we have to do now? We now have to factorize. Right, let's factorize. If we factorize here, we see what is common here and what is common here and there. It is 2 to the power of 2x, 3 to the power of 2x, and 3 to the power of 2x. Right, so let's take it out. If we take that out, then inside the bracket, remember what is it that we're going to have? We're going to have 3 to the power of 2 plus, and then here we're going to have a 3. All over at the bottom, we also have 3 to the power of 2x, and we also have 3 to the power of 2x there. So let's take it out. If we take it out inside, we're going to be left with 3 to the power of 2 minus, this is out, so we're left with minus 3. Right. If we continue with that, this and this will cancel. What is left on top is 3 to the power of 2, that's 9. 9 plus 3, that's 12. All over. And then here, 3 to the power of 2, that's 9. 9 minus 3, that is equal to 6. 12 divided by 6, that is equal to 2. Great. Thank you so much for watching. For more videos like this, please subscribe to our YouTube channel. I'm going to include the link. So just check for the link and then subscribe to our YouTube channel. Thank you. Right, so as promised, I've decided to include another example of addition and subtraction of fractions with variable exponents. Right, remember we said that during addition and subtraction of fractions with variable exponents, we reverse law number 3. So if you have a to the power of b plus c, we can also write that as a to the power of b times a to the power of c, vice versa. We do this to split the exponents. And then after that we factorize. So we are going to do the same here. Right, so let's split this. 3 to the power of 2x plus 2 can be written as 2 to the power of 2x times 3 to the power of 2. Plus this, we can split it to 3 to the power of 2x times 3 to the power of 1. I don't have to write the 1 because it will retain answer. Right, the same applies. 3 to the power of 2x times 3 to the power of 2. They are separated by a negative. Then this can be written as 3 to the power of 2x times 3 to the power of. Right, the biggest mistake that students always make, probably because of lack of understanding of algebra, they then tend to try to split, to cancel these. That's not correct. You are not allowed to do that because these are separated by a plus or minus, so you can't do that. So what is it that we have to do now? We now have to factorize. Right, let's factorize. If we factorize here, we see what is common here and what is common here and there. It is 2 to the power of 2x, 3 to the power of 2x, and 3 to the power of 2x. Right, so let's take it out. If we take that out, then inside the bracket, remember what is it that we're going to have? We're going to have 3 to the power of 2 plus, and then here we're going to have a 3. All over at the bottom, we also have 3 to the power of 2x, and we also have 3 to the power of 2x there. So let's take it out. If we take it out inside, we're going to be left with 3 to the power of 2 minus, this is out, so we're left with minus 3. Right. If we continue with that, this and this will cancel. What is left on top is 3 to the power of 2, that's 9. 9 plus 3, that's 12. All over. And then here, 3 to the power of 2, that's 9. 9 minus 3, that is equal to 6. 12 divided by 6, that is equal to 2. Great. Thank you so much for watching. For more videos like this, please subscribe to our YouTube channel. I'm going to include I'm going to include the link. So just check for the link and then subscribe to our YouTube channel. Thank you. Right, so now we are done with simplification of exponents using the definitions and laws of exponent. So what are we going to do now? Now we're going to do addition and subtraction of fractions with variable exponents. As you can see here that we have variable exponents. How do we then simplify, or how do we add or subtract fractions with variable exponents? Right, so here I included a note that is very, very important that you need to understand. So how do you go about solving this? So during addition and subtraction of fraction with variable exponents, we reverse law number 3. What is law number 3? Remember, if you have a to the power of b plus c, we can rewrite this as a to the power of b. We can split this to a to the power of b times a to the power of c. Right, so vice versa, we can do that vice versa. So we use this to split the exponent. We then factorize after that. Right, so let's apply law number 3 in reverse to solve this. Right, so how can we write 5 to the power of x if we reverse law number 3? By reversing law number 3, we can rewrite that as 5 to the power, okay, I actually don't have to write the 1, but it's fine. So for you to understand, so 5 to the power of 1 times 5 to the power of 2x minus 3 times 5 to the power, I don't have to split, I can split that to x plus x if I want, but I don't have to in this case because of the 2x, because I can see that there's a 2x, so I don't actually have to split. Then at the bottom, how can we write 25? We can write 25 as 5 to the power of 2, but because we have the x, so it will be 2x. And at the bottom you can see that these two are multiplied, so it's fine. So I can keep the 4 if I want. I can also write that as 2 to the power of 2, but why am I not even doing that? Why am I not bothering myself? Because I don't even see any base of 2 on top, so it's fine. I can keep my 4, right? Then what do we do after this? We then factorize. So let's factorize. What is common here and there? It is 5 to the power of 2x, so let's take it out. If we factorize that, you can see that, so take that out. So what is left is 5 to the power of 1, that's 5, minus 3 on top, and what at the bottom, we still have 5 to the power of 2x times 4. So we can factorize that if you want. You can also write it like this, right? So I decided to write it like this to show those who don't understand. So it's like factorizing, like what we did on top. We took out 5 to the power of 2x, and then we were left with 5 minus 3. So we can do the same at the bottom. So if we do that, then you can see that these two will cancel out. What is left on top is 5 minus 3, that's 2. At the bottom we have 4, and that is equal to 2 into 2, that's 1, 2 into, that's half. Great. Right, so I'm going to do another example. I'm going to include another example. So for more, just watch the next video. Great, thank you.